Okay, good evening, YouTube. Good evening, YouTube. Let's see if I can stream to Twitch now. Okay, apparently Twitch stream has started, so if it did, good evening, Twitch. Let me go to my page on Twitch to see if that really works. It doesn't seem to work. Huh. This is really, really odd. Golga Katani, good evening. What's up? Item stream. Item. Very warm. Yeah. It is warm, yeah. Amko, how are you on Twitch? Is my Twitch actually working? Oh, Twitch does work. I didn't even notice. Cool, 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 cool. So happy to see that work. Good, 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 good. Let me pop out the Twitch chat. Nice, nice. Good, good, good. I'm happy to see that working. Okay, OBS will go to that monitor. Okay. Let's see how do we crop this. We stopped somewhere here. Yeah, let's see where the crop is. Orientation, trim margins. Oh, it's already trimmed. Okay, in that case, nothing to trim. Okay. I'm just thinking where to put the chat. Iceblade, hello. Where to put the chat and my picture this time. Like, this seems to be the logical choice, maybe. I'm not sure. Maybe I can just cover the chat. It's not that important. Just a couple of last messages. Okay. Let me know if you want to chat for a few minutes, or shall we start working? I feel like not wasting too much time today. Chat activity is not that high at the moment. So we're starting level 1 to... Yeah. We came to level 1. By the way, Iceblade, the reason why I couldn't find my my saved code file last Sunday on the server is because the first one I did was actually on my here on my PC, right? This PC where I am at right now. But I'm gonna go and log into, where was it? Didn't I use the SSH? What was it anyway? I keep forgetting the IP address. 99.233 was it? Nope. 234. 232. 235. There we go. Okay. Yeah. The first code I did was locally on this PC, and since I didn't take this PC with me, this is a stationary PC. I went to my village with the laptop, right? So I couldn't find the code because the code was on this PC. Actually, this PC was on at the moment of the last stream, so I was able to SSH into this PC, no problem, because it was on. But I just didn't know that the code was here. So when I returned from the village, I just found everything in place as it was from the stream from 2 weeks ago. I haven't touched the PC for 2 weeks. It's actually quite hot in this room. I said that a couple of times already. It's not a good place to be. Okay, who is going to join? Will chat is now also blocking the oh, chat blocking the camera. Okay, I see that. Now is better. I switched the Z axis of the camera. Okay, we don't really need the code right now. I'm just gonna clear it like this. And okay, we have this, where's my mouse? We have this acquaintance title here, and then something called buckle up on the next page, and then the actual lesson starts. So let's read this quickly and see what it has in store for us. And we'll go from there. Okay, our mascot for this level, the common raven, is a very sociable corvid and known for its problem-solving capacity. Ravens organize in teams and have been observed playing even as adults. Okay. This level will acquaint you with the C programming language, that is, it will provide you with enough knowledge to write and use good C programs. Good here refers to a modern understanding of the language, avoiding most of the pitfalls of early dialects of C and offering you some constructs that were not present before and that are portable across the vast majority of modern computer architectures, from your cell phone to a mainframe computer. Having worked through these sections, you should be able to write shortcode for everyday needs that is not extremely sophisticated but useful and portable. So they say buckle up. In many ways, C is as permissive language. Programmers are allowed to shoot themselves in the foot or other body parts if they choose to, and C will make no effort to stop them. Therefore, just for the moment, we will introduce some restrictions. We'll try to avoid handing out guns in this level and place the key to the gun safe out of your reach for the moment, marking its location with big and visible exclamation marks. The most dangerous constructs in C are so-called casts. So we'll skip them at this level. However, there are many other pitfalls that are less easy to avoid. We will approach some of them in a way that might look unfamiliar to you, in particular if you learned your C basics in the last millennium, or if you were introduced to C on a platform that wasn't upgraded to current ISO C for years. I don't remember casts whatsoever. Experienced C programmers. If you already have some experience with C programming, what follows may take some getting used to or even provoke allergic reactions. If you happen to break out in hives when you read some of the code here, take a deep breath and try to relax, but please do not skip these pages. Inexperienced C programmers. If you're not an experienced C programmer, much of the following discussion may be a bit over your head. For example, we may use terminology that you have not even heard of. If so, this is a digression for you, and you may skip to the start of section 3 and then come back later when you feel a bit more comfortable. But be sure to do so before the end of this level. So I'm not sure. I mean, obviously, I'm an inexperienced programmer, but I feel like I want to go through everything step by step as it was written. I'm not sure if it's a good thing to listen to the author of the book and go back and forth. I'm not sure if I will be aware of when should I rewind. So let's read one thing at a time. Some of the read anyway. Some of the getting used to our approach on this level may concern the emphasis and ordering in which we present the material. We will focus primarily on the unsigned versions of integer types. We will introduce pointers in steps, first in disguise as parameters to functions. then with their state being valid or not, and then the next level using their entire potential. I'm just looking at section numbers here. Section 6, 162, and then section 11. If we scroll here, the pointer seems to be in the lesson 6, but lesson 11, where is 11? Oh, I see them, pointers. Okay, that's level 2. Okay. We will focus on the use of arrays whenever possible instead. You might also be surprised by some style considerations that we will discuss in the following points. On the next level, we will dedicate an entire section, section 9. Oh, that's level 2, okay, to these questions. So that's style. So please be patient and accept them for the moment as they are. We bind type modifiers, qualifiers, and attributes to the left. We want to separate identifiers visually from their type. We want to separate identifiers visually from their type. So we will typically write things as car asterisk name semicolon, where car asterisk is the type and name is the identifier. We also apply the left binding rule to qualifiers or attributes and write car const asterisk, another const path underscore name, and then deprecated in double square brackets. Here the first const qualifies the car to its left. The asterisk makes it to a pointer. And the second const again qualifies what it is to its left. The attribute deprecated clearly attaches to identifier path name. We do not use continued declarations. They obfuscate the bindings of type declarations, of type declarators. For example, unsigned const asterisk const a comma b semicolon. We do not use continued declarations. Continued declarations. I'm not even sure what they mean by continued declaration. I see why he said some people would not like the examples here. Yeah, I'm already lost. This feels like an example of what we will not do, right? So this is just an example of take it out. We're not going to do that. Here, B has type unsigned const. That is, the first const goes to the type, and the second const only goes to the declaration of A. Such rules are highly confusing, and you have more important things to learn. So, shall we skip it, or can we explain why this is as they say it is? Because I don't see it. How does B here has type unsigned const? The first const goes to the type. The first const goes to the type. The second as they say, declaration of A, and then B is what? Like a completely separate thing. Or am I missing something? I'm not sure. Okay, we use array notation. We use array notation for pointer parameters. We do so wherever these assume that the pointer can't be null. Some examples are as follows. These emphasize that the arguments cannot be null. Okay, size underscore t. I suppose this is string length. Best way Iceblade can describe it is that B is hi Alexei, by the way Twitch works. Is that B is the second one in inputs and it does not have a type, so it takes type value to the left, but half of it. Alexis says this is only confusing if they want to keep their awful style. If they explained how var declarations actually work, there would be no confusion here. I don't know how long a star actually bounds to the identifier, not to the type. Well, they did explain that above. Here, the first const qualifies the car to the left, and the asterisk makes it to a pointer. So here as well, the first const will, I guess, qualify the unsigned. And the second one, what does that do? Second one takes all of it together. You're going to have to pardon me, but I'm going to question a lot of things on these streams because it's really difficult to wrap the head, like wrap the completely blank head about everything here. I'm not even trying to be funny or something. It's just a lot of things to ingest from the get-go. I'm not saying it's difficult. I'm just saying it takes time, practice and repetition to find that aha moment, because genuinely, I don't understand anything here. And I'm not even sure if I am supposed to understand everything immediately, but rather read along and hope it will sit at some point. It reads as asterisk const a. Oh, uh, I didn't think so. I mean, up until now, I realized that the pointer declaration, or whatever you want to call the asterisk, usually comes afterwards. So whenever I see the asterisk, I am kind of aware that it's bundled with the first one and not with the second one. And you guys already told me that spaces are whatever. So if spaces are whatever, then asterisk goes with the word on the left. Alexei says C. What is VA? C va declaration style is confusing until you understand it. Yeah, that's what I was hoping for. In the sense of let's go ahead until it sits. Iceblade says this was the bit they said unexperienced could skip but should not. Var. Variable, okay. They did say that experienced programmers might get very angry about what they will see in here, and inexperienced ones should or could skip it, but come back to it later. So I don't feel too bad about not understanding. They try to hide how C declarations actually work, and since hiding it leads to issues, then they try to ban examples of when it leads to issues. You're talking about this particular book, I suspect. Mhm. Okay, I'm not going to hold for much longer here because clearly I'm not going to understand what this is. I will try to read it, but then I'm going to move on because the book author said so. Like, don't sweat it too much if you can get it from the first attempt. So, the first problem, consider these bad examples for now. Yeah, it's fine. So the first problem, you're mostly against one. But as I understood, they are giving example one as an example of shit. I don't believe they want to teach me this in this way. But okay. So what is I'm reading this as string length or something like that. strlen. I don't know what this is supposed to be. It could be string length. So string length is, and that is what I don't agree with in particular because of what they infer from it. Okay. So string length is about size underscore t, or is it? Or is this? Uh, I can't even read this. I can read it out loud, but I don't understand which defines what. I mean, size t is a type this function returns. And we know that it is a function because of what exactly? I already declared something because it follows C function declaration grammar. Yeah, that's what I'm asking. What is the grammar? Because the last time I believe I proclaimed something to be a function, but it was actually only a part of the function. Type name parameters list in parentheses function code name returning type and accepting parameters list. So that's still the part where I struggle. I don't see how is it accepting parameters list. Okay, this is an array. Okay, let's try to unpack this, or rather I will try to unpack this and you can correct me. So this part seems to be some kind of array. Static one something something. So here is the function string length returning size t and accepting string. Yeah, it's accepting string, that much I can see. Which is an array of char constant characters. That's pretty difficult to wrap the head around. Static one basically means that array size should be at least 1. How did we decide that this means it should be at least 1? Is, let's say that that's a little bit advanced for now, but this definitely is an array for the string. Don't sweat it. This is for people already knowing. Yeah, that's what I thought. But I should be able to understand at least some basics. Static, the array of the string is how I need the pen. Why is the pen not working? Give me just a second. I don't like when things don't work. Drawing tablet, no tablets found. That could be a problem. Oh, the battery. The battery died. I was wondering how long does the battery last on the tablet? Charger. Oh, there it is. Okay. Now it works. You can omit static 1 size t string length character constant string check manual string length. Everything is going according to plan. Yeah, so this part is slightly confusing. We have this here, and I don't know. Oh, okay, now it's better. Why is it so bold? Lighter. 2, 1. Okay. This part here is an array of strings. And what bothers me is how does it apply to the shit, sorry, to the shit on the left? How? No? String is the name of the parameter. A name of the array. Okay, that may make a little bit more sense. If that's just a name, you could write it as size t string length character const foo. Well, that's pretty much the same. Katalin, sorry, I can't pronounce the last name. Shiminiuch. I'm watching out of curiosity since I'm trying to learn JavaScript and coming along with everyone's expectation. I'm having the same questions. Thanks for the explanations, chat. Yeah, just a short explanation here. If you're first time the stream, I'm not really a C programmer, but rather we're kind of learning together. Alexei is the most knowledgeable here, which is kind of counterintuitive from a live stream. You know, you would expect me to be the teacher, right? But Um, Overall, it's working pretty fine as a small community. So Iceblade knows something. I have some basic understanding of programming, but not C. And we picked a fairly okay book, which has a license that I can actually show it on stream and not get punished. But yeah, the entire idea is that we should communicate as much as possible through chat and me through the microphone. So together we will come up with some answers there. But don't worry about it. The more you speak in chat, the better the stream gets. I'll move to Twitch soon. Yeah, it's fine. When you move to Twitch, then we will read your stuff over here. So what I meant is this array is like you said what to read in the manual. Check manual string length. Oh, this one. Okay, let's do that. Calculate the length of a string in standard C library. Include string.h, size t, string length, const character pointer s. Or this is not pointer s. Or this is like what the hell is this? You guys told me that spaces don't matter, so why is this asterisk attached to the to the name of the that is a pointer. If that is a pointer, then why is it not attached to the word car? Pointer to string named s. Okay, so this is really confusing now. Up until now, I thought that the asterisk only comes on the right side. Okay, so what if I type it like this? No asterisk anywhere since no spaces. What if I type it like this? Did I change anything if I do that? I moved the space and I don't think I changed anything. Iceblood says car asterisk is the same as car. Yeah, okay. In type asterisk A, it is not A that is type asterisk, but it's actually asterisk A, which is type. Okay, that is a little bit troublesome. Both type asterisk space A and type space asterisk A are equivalent in C grammar. Okay, so that much I understood so far, but I'm trying to figure out why in some places I see people put space on the left and sometimes on the right. That's personal preference. Okay, I'll figure it out eventually. The string length function calculates the length of the most common is star on the left of identifier. Catalin, or is it Caitlin? No, Caitlin would be female name. Catalin then. And what are the best practices for easier read and writing code? I'm sure guys in chat will answer that one, but in my opinion, I think it would matter more to understand how pointers are actually working in terms of syntax. Okay. Anyways, what is the button? Typewriter, no. Inline note, pop-up note. Oh, that's what I need. Int main. Int main. These emphasis, blah, blah, blah. Okay. Int main, int argc, comma. Yeah, so this is going to drive me crazy, guys. This is the same book author. What is he trying to tell me? I'm just thinking something in my head. Alexei, I might take you up on that Yandex offer soon-ish, but obviously not today. He tells you that these are the same. Gulag. You wrote Gulag. Okay. Int main in argc, comma, character asterisk argv, argc, compatible declarations for the same functions. Size t, string length, const. So he flipped it. Catalin says, I read that line as function name size underscore t, which is a string, have the following parameters for string. Type of the variable is a character with which is a constant of type string, which should be at least one. Feels like Gulag here. Yes, that's good. Iceblade saying, yeah, C has like type to left and name or variable to right, like int1 and char a. Okay. Let's go ahead. The whole section is called buckle up, so that's what I'm doing. The first example stresses the fact that string length must receive a valid non-null pointer and will access at least one element of string. The second summarizes the fact that main receives an array of argc plus 1 pointers to car, referring to the program name, to argc-1 program arguments, and to one null pointer that terminates the array. The second set of declarations only adds additional equivalent declarations for features that are already known to the compiler. Because these are declarations and not definitions, such a redeclaration is allowed, but it doesn't add new information in this case. Okay, we use function notation for function pointer parameters. Along the same lines, we do so whenever we know that a function pointer cannot be null. This emphasizes that the handler argument cannot be null. Integer, I don't know how to read this. At exit. What is at? Or is it at exit? At exit, okay. Integer at exit void handler void. Compatible declaration for the same function. Integer at exit void. Okay. Skip this for now. By the way, did you, I am not sure, were you on stream, Alexei, when it said, if you already have some experience, this part might provoke allergic reactions. If you are inexperienced, then skip. You may skip to the start of section 3. I will speed it up just a little bit. Here, the first declaration of at exit emphasizes that semantically it receives a function named handler as an argument that a null function pointer is not allowed. Technically, the function parameter handler is rewritten to a function pointer, much as array parameters are rewritten to object pointers, but this is of minor interest for a description of the functionality. Rutlex says the issue is you don't know what pointers are, let alone function pointers, so skip to 4. Okay. Note again that the previous code is valid as it stands and that the second declaration just adds an equivalent declaration for at exit. When he said skip to 3, he didn't mean this 3 and 4. He meant He meant this number 3. Anyways, we defined variables as close to their first use as possible. I meant that for. Okay. We define variables as close to their first use as possible. Lack of variable initialization, especially for pointers, is one of the major pitfalls for novice C programmers. This is why we should, whenever possible, combine the declaration of a variable with the first assignment to it. The tool that C gives us for this purpose is the definition, a declaration together with an initialization. This gives a name to a value and introduces this name at the first place where it is used. This is particularly convenient for for loops. The iterator variable for one loop is semantically a different object from that in another loop. So we declare the variable within the for to ensure it stays within the loop's primary block. Okay, we use prefix notation for code blocks. To be able to read a code block, it is important to capture two things about it easily: its purpose and its extent. Therefore, all curly braces are prefixed on the same line with the statement or declaration that introduces them. The code inside is indented by one level. The terminating curly starts a new line on the same level as the statement that introduced the block. Okay, so that's more about the style. I don't believe that C cares about that, the compiler. Block statements that have a continuation after the closed curly continue on the same line. See the following code snippet as an example. Okay, int main, int argc, char asterisk argv. Okay, so that's the function that starts. And where does it end? Here. C doesn't care, only people reading the code do. Yeah. Okay, so it starts here, ends here. We have one if here that opens up here and over here. No, here. It ends here. So I can see where it ends. I'm just following along. And we have else that ends here. Okay, so this one closes the main function. We use digit separators for numbers. Just a second. Okay, we use digit separators for numbers. The human eye is not very good at perceiving the magnitude of numbers that have many digits. Uh, in running text, we therefore use a comma as a thousandths separator for large decimal numbers. And we even extend this form of notation to digits after the period, as in, for example, like that. You know what's funny? Just as a small observation, uh, I'm not sure if in Croatia it's actually the comma that is a decimal separator, while we use the dot over here. But okay. Rotlex says he thinks it looks even more confusing. Uh, I'm not sure. If I were me, I would most likely just put the dot and nothing else, and then use the highlighter function of the editor to count how many blocks of tree do I have. Because when I'm how would I say it? We will see how it goes. I don't believe that I need the commas, exactly because how I am used to reading the text that has large numbers, right? I just go with my highlighter and go three at the time. Like this is one, this is two, so it's, you know, anyways, this is very locale dependent. Yeah, that is actually a major issue. Sorry for a small digression. It's not really about programming, but it's about Microsoft Excel. In my workplace, I used to have a lot of need to edit the CSV files, comma separated values files, that would be like columns that would be separated with commas because it's a CSV file. And I would try to edit that in Excel and it would work. But when I would press save in Excel, then Excel would replace all of the commas with semicolons, uh, because for some weird reason in the Croatian locale, Excel thought that it is a very good idea to change the commas in the CSV file for semicolons. And of course, that wouldn't work where I would need to import that file. So after editing in Excel, I would have to do search and replace in Notepad++. That's where LibreOffice is a lot better. Yeah. A notable exception from this rule is years where we do not apply a thousandths separator. Since C23 There is also a digit separator for number literals, namely an apostrophe that appears directly between two consecutive digits, such as in this number here. We use that for all number literals by grouping together 3 decimal digits for thousands, 4 hexadecimal digits for double bytes, and 8 binary digits for the bits in a byte. I don't get it. How is this different than this? I don't know. This looks even more stupid, but I suppose it's nice to be aware that such a thing exists. Okay, so today's lesson starts now. Everything is about control. This section covers conditional execution with if, iterating over domains, making multiple selections. In our introductory example, listing 1.1, we saw two different constructs that allowed us to control the flow of a program's execution, functions, and the for iteration. Functions are a way to transfer control unconditionally. The call transfers control unconditionally to the function, and a return statement unconditionally transfers it back to the caller. We will come back to functions in section 7. The for statement is different in that it has a controlling condition I. Why is my Twitch reconnecting? What's happening to Twitch? Is my Twitch dead? No? Okay. Okay, it's jammed for me. I cannot see your chat. You're live? Oh, now I can see it. Okay. It's probably an error on my end as a client that watches myself. You paused? You think so? Uh, okay, let's go ahead. Everything seems to be fine right now. The for statement is different in that it has a controlling condition, I being less than 5 in the example, that regulates if and if so when the secondary block printf is executed. C has 5 conditional control statements. If, or, do, while, switch. We will look at these statements in this section. So if introduces a conditional execution depending on a Boolean expression for, do and while are different forms of iterations, and switch is a multiple selection based on an integer value. C has some other conditionals that we will discuss later. The ternary operator, denoted by an expression in the form condition question mark a. What is this? Let's just say that this is AB. The compile time preprocessor conditionals. If def, ifn def, elif def, elifn def, else and if. I think I read that properly. And type generic expressions denoted with the keyword underscore generic, section 18. Conditional execution. So this is the first lesson out of 3 of them today. Or should I say first sub-lesson of 3 sub-lessons in total. A peculiar chapter for beginners. We're past beginners, I think. Okay, conditional execution. The first construct that we will look at is specified by the keyword if. It looks like this. If I is bigger than 25, then execute this. J equals I minus 25. Here we compare I against the value 25. If it is larger than 25, J is set to the value I minus 25. In the example, I is bigger than 25 is called the controlling expression, and the part in the curlies is called the secondary block. Okay, so this is called secondary block. I think that's easy enough to remember. On the surface, this form of an if statement resembles the for statement that we already encountered, but it works differently than that. There is only one part inside the parentheses, and that determines whether the secondary block is run once or not at all. There is a more general form of the if construct. Iceblade calls the secondary block as intestines. There is a more general form of the if construct. If I is bigger than 25, then intestines say the following. J equals I minus 25, or else J equals 1. It has another secondary block that is executed if the controlling condition is not fulfilled. Syntactically, this is done by introducing another keyword, else, which separates the two secondary blocks. The if and else is a selection statement. It selects one of the two possible code paths according to the contents of the parentheses. The general form is if condition in parentheses, then secondary block, or else another secondary block. The possibilities for condition, the controlling expression, are numerous. They can range from simple comparisons, as in this example, to very complex nested expressions. We will present all the primitives that can be used in section 4. The simplest of such condition specification in an if statement can be seen in the following example in a variation of the for loop from listing 1.1. So then it says for size t I equals 0, I is less than 5, and then we are counting the I upwards, adding 1 in each loop iteration. So if I, okay, this is confusing. What does it mean if I incrementing? Okay, that's what I meant, but was difficult to express myself. If I, this reads to me like go ahead and execute as long as I exists. Am I correct? Read next. Okay. Printf element. I forgot what that is. But anyways, printf, whatever this is, I, a of I, know if I is true or false. Okay, I was close enough. So this is if I is true. Here the condition that determines whether printf is executed is just I. A numerical value by itself can be interpreted as a condition. The text will only be printed when the value of I is not 0. Okay, I was close enough. There are two simple rules for the evaluation of a numerical condition. Okay, so the takeaways. The value 0 represents logical false. Any value different from 0 represents logical true. Okay. Rutlag says it is explained below the code block. I am fairly aware that the book tends to, and has been doing that since the past 2 lessons, the book tends to explain stuff under the code block, but I intentionally don't draw my eyes on the explanation immediately because while in the most cases I will not be able to decode everything, I do want to give it a try and see what I stumble, and then read the answer, right? I understand that I could pretend that I don't understand shit and then read the answer, but it feels like it would be good if I used at least a little bit of my brain effort to try to understand this. No matter that I will fail more than I will not, but eventually I will be able to read everything in here without looking at the solution, so to speak, right? That's my goal. The operators equals and exclamation mark equals allows us to test for equality and inequality. Guhan just subscribed. Thanks a lot. Respectively, A equals B. Guhan, you can now chat if you want. The respect A equals B is true if the value of A is equal to the value of B, and false otherwise. A exclamation mark equals B is false if A is equal to B, and true otherwise. So it's basically vice versa. No subscriber chat rule must be subscriber for 5 minutes or more. Really? I think I set it up to 0. Could be Twitch. I get more spam on Twitch. It's not here at the moment. I don't know. When joined chat, it said that message. New guy who just subscribed. If you cannot type just yet, wait 3 more minutes and let us know if you needed to wait 5 minutes to chat, because I really thought that I have set it to 0 minutes. I apologize if it's 5. It wasn't intentional. Knowing how numerical values are evaluated as conditions, we can avoid redundancy. For example, we can rewrite. Iceblood says also if it was a YouTube subscribe, it might be random video they watched. Yeah, it could. Yeah, it could. Catalin says I could had type right away after subscribe. Thank you. That's what I thought, because I have had this interface open just before the stream, and I was pretty sure that I have set it to 0. Okay, knowing how numerical values are evaluated as conditions, we can avoid redundancy. For example, we can rewrite if I is different than 0, then do something. We can rewrite that as if I is true, I suppose. I like these. I like these little games here. I think I already learned something. Which of these two versions is more readable is a question of coding style and can be subject to fruitless debates. I'm just considering for a moment, why would it be a question of like a subject of fruitless debate? Fruitless debate sounds like programming wars, right? Or something along those lines. Like you should or shouldn't do it this way because I said so. I mean, if you have the knowledge, then surely you should be able to read this just as you should be able to read this as well. In Matrix, I showed picture of message if you wanted to see. I cannot make it bigger. Subscribers only mode. Messages that appear are from people who have subscribed to this channel for 5 minutes or longer. Huh. I don't know. Okie dokie. Well, the first might be easier for occasional readers of C code to read. The latter is often preferred in projects that assume some knowledge about C type system. The type bool or boolean should be used to store truth values. Its values are false and true. Technically, false is just a value 0 of type boolean, and true the value 1. It is important to use false and true and not the numbers to emphasize that the value is to be interpreted as a condition. We will learn more about booleans type in the section 5. Note that before C23, to use boolean and its literals, false and true, you had to use the standard boolean.h header. This is now obsolete, and you should only use it if you suspect that your code may be compiled on an older platform. Redundant comparisons quickly become unreadable and clutter your code. If you have a conditional that depends on a truth value, use that truth value directly as the condition. Again, we can avoid redundancy by rewriting something like boolean b equals something, and then if b isn't false, then it must be true. Oh, there's more. Boolean b equals something if b is true. Okay. Don't compare to 0, false, or true. I'm not sure what this sentence is trying to say. Using either the truth value directly, such as I above, or the negation denoted as exclamation I in C, makes your code clearer and illustrates one of the basic concepts of the C language. All scalars have a truth value. Now, I'm gonna be honest, I don't know what a scalar is. So if someone who went to college can teach me what scalar is, do tell. Here, scalar types include all the numerical types, such as size underscore t, boolean, and integer that we already encountered, and pointer types. See table 3 for the types that are frequently used in this book. We will come back to them in section 6. Color is read next. Okay. Where did iterations start? Am I blind? Oh, here. That's a weird switch to 3.2. Oh, here it is. Okay, sorry, here it is. Yeah. Okay, sorry. I saw it on the left side. I saw it here that we are now on iterations, and I was wondering when did we get there. By the way, what was it? Control Alt? No. Alt Shift? No. Control Shift? What was that zoom thing? Alt Super? Nope. Super Control. Oh, there it is. Super Control. That's what I meant. We are on iterations here, and I didn't really see it below. Okay, so super control. Okay, I need to remember it. I think I need a little bit of throat oil, so to speak, engine oil. I'll be back in a sec, because if I don't lubricate the throat, it will get worse. Okay. Scholars. Hmm. Scholar types used in this book: level 0, size T, double, signed, unsigned, boolean, category, unsigned, floating. Signed is signed, unsigned is unsigned, boolean is unsigned. Where standard definition, built in since 23. By the way, Rootlex, you have mentioned to me at least on 2 occasions something along the lines how maybe I remembered it wrong, but you said something like C is not rich enough, or that you wished that it was richer in terms of what it can do. Something along those lines. I'm not. Maybe you can, if you remember what I'm talking about. I'm just trying to figure out something. If these things are built in to the language, then how come size underscore T unsigned is considered not built in if I don't really need anything other than call the I'm a little bit confused. Is this not a part of the standard as well? It is, yeah. So as far as I understand it, it is a part of the standard. It's just that they made it so that you need to call it, I suspect, in order to save memory. Because why would you load something that you don't need? That's how I see it. Size T is just not a native type, but is an alias to some native type. Hmm. Okay. This table here really needs, it's like having the, I think I should print all of these percentages for myself on a piece of paper or a cardboard to have as a reference until I remember them all, because it's really cumbersome to go through manuals to see which ones are which every single time. And if I just keep them on the table for a while, I might actually remember them. For example, Rootlex says it's probably defined as unsigned long on your system. PTR pointer difference underscore T signed. You don't need to write them down. Man, print is your friend. Remembering it about and remembering is about actually using them, not looking at. That was the same thing when I said it. I didn't mean um, I didn't mean like having them on paper and just looking at them. I meant more like when I need them, I would have a quick glance of the eye to see them instead of going into the manual, because I think, or at least I believe, that I'm going to need them pretty often. So if they are already in my eyesight, it could be a little bit faster than going through manual. What are the levels? Oh, that's the book level. Okay. Okay. Never mind. I got it. It's the level in the book. Okay, let's go with the middle lesson. Iterations. Previously, we encountered the for statement to iterate over a domain. In our introductory example, it declared a variable I that was set to the values 0, 1, 2, 3, and 4. The general form of this statement is for clause 1, condition 2, expression 3, and then the secondary block. This statement is actually quite generic. Usually clause 1 is an assignment expression or a variable definition. It serves to state an initial value for the iteration domain. Condition 2 tests whether the iteration should continue. And then the expression 3 updates the iteration variable used in clause 1. So this is the, how did you call it? The plus plus I. Iterator. Increment. Increment. That's what I meant. Increment. No, no. I meant increment. Anyways, it is performed at the end of each iteration. Here is some advice. Because we want iteration variables to be defined narrowly in the context for a for loop, clause 1 should in most cases be a variable definition. Because for is relatively complex with its 4 different parts and not easy to capture visually, the secondary block should usually be a compound statement indicated by curlies or curly braces. Let's see some examples. For size underscore t I equals 10, if I is true, maybe, decrement the I. What I am not a fan of in this book is that with general C knowledge, author mixes in his personal preferences regarding code style and such. Yeah, you already warned me about that, so I think I am already mentally prepared to, well, let's put it like this. when I see something about the style that doesn't sit well with me, I'm probably going to change it in my code. I don't really have to do it in the same way, but I think it is good that we have some different styles ahead of us and that I should be able to read all of them. So here it says I is 10. I'm not sure what size underscore t is here. It's a scholar. Unsigned. But okay. Anyways, I is 10. I exists. Or if I exists. If I is not 0. Let's go. Okay. I see what's going on here. Okay. So we are going to execute something. And then we are going to for loop this thing. And I is going to be 9 in the second run. And it will still exist. So we are going to execute again. And we are going to execute until I becomes 0. And then we will no longer execute. And then we're done. That's how I see it. This one here is waiting for I to become 0 so that for loop can stop. See? Okay, second one. 4. So consider size t as a kind of integer. Okay. Here we have I starting as 0. So he also said you should not use numbers, then later uses a number for Boolean. I think this is Boolean and not this. This here is Boolean. This is just a value of I. But this be Boolean. This is a bully. Okay, so how about this one? I is 0 and the condition here says it's rather bullshitian. Oh, okay. The condition here says stop equals upper bound. I have no clue what is going on here, but stop equals upper bound. I don't know what upper bound is. It's not a condition. It says here that the second field is condition. So did the book fail to teach me what the second position is? Or did the book try to do it right, but I misunderstood? Oh, sorry. Sorry, this is the second position. No. Sorry. The comma, the comma has fooled me. This is the condition. Okay. So I is 0. Stop is upper bound. Okay, I suppose I'm gonna figure it out eventually. So we are looping as long as I is less than stop. As long as I is less than stop. Okay, so we start here with something else. And we are working on the I. And we are incrementing here. So now I is 1. In the second run, I is 1. And this is confusing me. Stop is up. What the hell is upper bound in this entirety here? Is this something that I was supposed to declare earlier? So they are simply not showing it here? So I pretend stop is 10. Okay, so that is something that I should have declared somewhere. Some example. Okay. I get it. Okay, so I just pretend. Okay, then if I pretend that upper bound is 10, then this is going to loop 10 times. I don't see anything else here. Okay. In this case, I is 9. So as long as I is less than or is this less than or equal to 9? Yeah. We are going to run it and so we need equal in order to start. We need equal in order to start because it's already 9. We could have simplified it by making it less than 10, I suppose. But fine. Okay, so we go backwards again. We go backwards again, but this is not going to stop. This one is never going to stop. Iceblade, do you agree that this is not going to stop? Anyways, let's see what the text says. For the first 4 okay. The first 4 counts I down from 10 to 1 inclusive with the 1. The condition is again just the evaluation of the variable I. No redundant test against value is required. When I becomes 0, it will evaluate to false and the loop will stop. The second 4 declares 2 variables, I and stop. As before, I is the loop variable, stop is what we compare against in the condition, and when I becomes greater than the equal to stop, the loop terminates. Okay. The third 4 looks as though it would go on forever, but it actually counts down from 9 to 0. In fact, in the next section, we will see that sizes in C, numbers that have size t, are never negative. Observe that all three for statements declare variables named I. These three variables with the same name happily live side by side as long as their scopes don't overlap. Okay, so it stops because it cannot go into the negative because of the size t. What did I do? Fuck. I pressed the scroll wheel by accident. Okay. Oh, I wanted to see size t. Okay, here is not clear that it cannot be negative. Go to page 39. Okay, we will get there. Observe that all three for statements declare variable. Oh, sorry, I read that already. There are two more interactive statements in C, while and do. Okie dokie. While condition, do the block. Unsigned means not negative. Okay. Okay, I didn't know that. Okay, while the condition, do the block. Oh, it's secondary. Why secondary block? That part is confusing. Anyways, while condition, secondary block, do secondary block. While, okay, this is confusing. I need an example. It actually stops because it becomes very large instead of negative. Oh, you mean it loops? The following example. Yeah, okay. The following example shows a typical use of while. It implements the Heron approximation to compute the multiplicative inverse 1 divided by x of a number x. Okay, include TG math. So that sounds like trigonometry. Const expression double. Okay, so what the hell is that sign? Epsilon. Okay. You must be aware that I was quite bad at math, and then I didn't go to college. Math epsilon, I think. Okay. But surely, Iceblade, you went to college, or you are doing that now. Anyways, you don't have to answer that. Nope, you didn't. Okay. Okay, let's just go on with the fact that this is desired precision. Double const A is 34.0. Okay, it's float, double float. Double x equals 0.5, while fabs okay, while fabs 1 minus a times x greater than epsilon. Do some math in here. Okay, so I'm really not going to stop here, but rather I'm going to read the stuff below, because my math skill is going to prevent me from reading this C code, because the C part is not that difficult to read here, but the I mean, this is just division. Or is it division? No, division is something else. How do you read minus? Substitution? No. Subtraction. Subtraction. This is subtraction. Yeah, okay, sorry. I have a lot of creation words in my head, and I simply never talk to any living human being about any of these signs. Never in my life. I just don't ever mention any of them ever. Call it minus. Okay. Anyways, it iterates as long as the given condition evaluates true, namely as long as the absolute value of the difference between 1 and the computed product is smaller than named constant called epsilon, which represents the desired minimum precision of the computation. The do loop is very similar, except that it checks the condition after the secondary block. Okay, do something. Then we have the math. And then we do it while this, I mean, the math may seem uncomputable to my head right now, at least this one. But the do while thingy seems fairly easy. I also think that I used do while in high school in Pascal, Turbo Pascal, whatever. This means if the condition immediately evaluates to false, a while loop will not run its secondary block at all, but the do loop will unconditionally run its block at least once before ever looking at the condition. As with the for statement, with the do and while it is advisable to use the curlies variants, there is also a subtle syntactical difference between the two. Do always needs a semicolon after while condition to terminate the statement. Okay, Rootlex. I'm looking at the Heron approximation at this very moment as something that is like one of the many math examples that can be used to control the loop, if that makes sense. So someday when I will understand that my program needs any kind of math to control the loop, I will not really have a problem with coming up with a math solution. And not that I have to, come up with math on my own. I can always use some examples from the internet. It's just the fact that what needs to sit in my head, and it already does because it's kind of logical, is that you can use math to control the loop, and that's all I need to remember. Let's hope this stream is not banned for formulas for Heron approximation. Yeah. By the way, the first time when I muted myself and talked to my wife, she played the music because she was doing uh, she has a physical lesson of her own, physical exercise that she likes to do with music, and I muted myself immediately because YouTube always punishes me whenever it hears any kind of music. That's kind of sucky. I had to tell her to shut the music down. I feel a little bit bad about that, but later we will see that this is a syntactic feature that turns out to be quite useful in the context of multiple nested statements. See section 10. All three iteration statements become even more flexible with break and continue statements. A break statement stops the loop without re-evaluating the termination condition or executing the part of the secondary block after the break statement. Okay, so while it is true, do the block. Okay, if fabs 1 minus prod is less than epsilon, then break. Stops if close enough. X. What is this? This is multiplication or equals. This is confusing. Times equals? What the hell is times equals? Current value times the new one. Okay. Okay. Rootlex, thank you. Iceblade's explanation was good enough. This is actually worth remembering. This way we can separate the computation of the product A times X, the evaluation of the stop condition, and the update of X. The condition of while then becomes trivial. In other words, plus plus I equals to I plus equals 1. You will probably forget. And okay. The same thing can be done using for, and there is a tradition among C programmers to write it as follows. For semicolon, semicolon, whatever the hell that means, go with the block double prod if fabs stops if close enough. Okay, so the entire block is the same except that for is looping double semicolon. For semicolon semicolon here is equivalent to while it is true. The fact that the controlling expression of for, the middle part between the double, the middle part between the, what? The fact that the controlling expression of for, the middle part between the semicolon, semicolon, what does it mean between the semicolon? Between what? Semicolon? Yeah, whatever. I'm highlighting what I'm reading because it makes it easier for you to detect when I read it wrong. The fact that the controlling expression of for can be omitted and is interpreted as always true is just a historical artifact in the rules of C and has no other special purpose. Rudlock says, remember it's for clause condition expression. They are just omitted entirely. Okay. Okay, I think I can see how this is true, since we didn't define it. So, nečestito. Present. The continue statement is less frequently used. Brushed teeth already? Yeah. By the way, or if I have. Do you know what this is? This is going to leave a lot of black dots on my teeth. And of course, I don't know food names in English because I don't use that as well. Mak, yes, it is mak, but it's mak in Croatian. But what it is it in English? No idea. Like break? Like break, continue skips the execution of the rest of the secondary block. So all statements in the compound statement after the continue are not executed for the current iteration. However, it then re-evaluates the condition and continues from the start of the secondary block if the condition is true. Golga Catania, I have no clue. Okay, so we have checks if we are on the correct side of 1. If x is bigger than 1, then x is 1 divided by itself, and then continue. And once again, the continue it skips the execution of the rest of the secondary block. What is the secondary block? This one. It skips the execution of the rest of the secondary block. So if this is the secondary block, then it skips nothing because there isn't anything in the rest of the secondary block. However, it then re-evaluates the condition goes straight to the next iteration. I'm gonna need a better example for continue. You can think of continue as it immediately jumps at the end of the loop block and goes on from there. Okay, that will do for now. In these examples, we use a standard macro fabs which comes with the TG math. I still didn't get the answer if that's trigonometry math, but okay. Header. It calculates the absolute value of a double. Listing 3.1 is a complete program that implements the same algorithm where fabs has been replaced by several explicit comparisons against certain fixed numbers. Znoj. That's probably... Oh! I thought it was installed. It is hot indeed. Yeah. So not that man page. Glibs. Is that correct? It says man pages. Man pages. POSIX dev. Much better. Luckily, I didn't even read it. This manual page is part of the POSIX Programmer's Manual. The Linux implementation of this interface may differ. Consult the corresponding Linux manual page for details of Linux behavior, or the interface may not be implemented in Linux. Type generic macros. The functionality described on this reference page is aligned with the ISO/C standard. Any conflict between the requirements described here and the standard is unintentional. This volume of POSIX.1 2017 differs to the ISO/C standard. The tgmath.h header shall include the headers math and complex and shall define several type generic macros. Of the functions contained within the math and complex headers without an F, float, or L, a long double suffix, several have one or more parameters whose corresponding real type is double. Yeah, in order to read this with more understanding, I need to have a need for it. Because just reading it like this will not get me any. It will not fit into my RAM. For example, EPS 1M24 defined to be 1 minus 1 times 2 Yeah, I know what this is, but once again, I cannot read it in English. Or EPS 1P24 as 1 plus 1 times 2 blah blah blah. We will see later in section 5 how the literals 0 times 1p minus 24 standing for the value and similar used in these definitions work, how they interact with the const expression construct. Power, okay. Okay, the power. Kamera u mene gleda. Get back to lesson. Okay, so this is 3.1, is it? Listing 3.1, computing multiplicative inverses of numbers. Guys, there is too much math here. Lower and upper iteration limits centered around 1. Const expression double EPS 1M01. What is this? A network card? This could be read as epsilon. No, I don't know what this is. But it's equals to 0 minus something. Okay. Well, they are defined here, whatever the result is. Int main, int argc, character, argv, argc, plus 1. Skip this. Okay. I was starting to feel that it will be a big pain to read this without any of the understanding. In the first phase, the product of the current number under investigation A with the current estimate x is compared to 1.5 and 0.5, and then x is multiplied by 0.5 or 2 until the product is close to 1. Rootless is no fun. Then the Heron approximation as shown in the code is used as a second iteration to close in and compute the multiplicative inverse with a high degree of accuracy. The overall task of the program is to compute the inverse of all numbers that are provided to it on the command line. An example of a program execution looks like this, and it looks like skip this. The process to process the numbers on the command line, the program uses another library function, strtod. Okay. Challenge 1: sequential sorting algorithms. Can you do a merge sort with recursion, a quick sort without recursion? On arrays with sort keys as double or strings to your likings. Nothing is gained if you don't know whether your programs are correct. Therefore, can you provide a simple test routine that checks whether the resulting array really is sorted? This test routine should just scan once through the array and should be much faster than your sorting algorithms. That's a challenge for Iceblade. I'm gonna give that as a homework for you. Multiple selection. Part 3 of 3. String to double. Okay. Can we kill the program if we attempt string to double something that isn't a number, like a letter? No question. Forget it. Was a joke. The last control statement that C has to offer is the switch statement. which is another selection statement. It is mainly used when cascades of if-else constructs would be too tedious. So if something puts something else if another else if another else if another else if, okay, so we have quite a lot of if statements here. In this case, we have a choice that is more complex than a false true decision, and that can have several outcomes. We can simplify this as follows. Switch with the argument, and in case it's M, do something and break. In case it's something else, do so. It's not very different, is it? Maybe, but this is highly subjective. Maybe it looks a little bit better to the eye. Just a smaller if block, kind of. Yeah, it's kind of subjective, I think. Switch is faster to execute, but it's generally the same. Use whatever you want. Is it faster to execute because of the breaks? Here we select one of the puts calls according to the value of the arg variable. Like printf, the function puts is provided by standard input output if it outputs a line with the string that is passed as an argument. We provide specific cases for characters M, R, J, C, and a special case labeled default. The default case is triggered if arg doesn't match any of the case values. No, because it uses binary search instead of testing each condition one by one. Okay. Syntactically, a switch is as simple as switch expression secondary block. And its semantics are quite straightforward. The case and default labels serve as jump targets. According to the value of the expression, control continues at the statement that is labeled accordingly. If we hit a break statement, the whole switch statement in which it appears is terminated, and then program control is transferred to the next statement after the switch. By that specification, switch statements can be used much more widely than iterated if-else constructs. Okay, so switch count default puts. Okay. Prior to C23, this needed an extra semicolon. Can I still put an extra semicolon? As far as I understand, C is backwards compatible, right? So whatever the C23 compiler understands, it will be able to understand anything written for previous standard, right? So I can still put a semicolon here if I want. I just need to understand that if I forget it, then only the latest compiler will be able to deal with it. Once we have jumped into the secondary block, execution continues until it reaches the break or the end of the block. In this case, because there is no break statements, we end up running all subsequent puts statements. For example, the output when the value of count is 3, a triangle with 3 lines. Oh. Okay. I wasn't even sure what we are doing here. The structure of a switch can be more flexible than if-else, but it is restricted in other ways. Case values must be integer constant expressions. Case values must be unique for each switch statement. Okay. In section 5, we will see what these expressions are in detail. For now, it suffices to know that these have to be fixed values that we provide directly in the source, such as the 4, 3, 2, 1, 0 in the previous example. In particular, variables such as count are only allowed in the switch part, not in the individual cases. With greater flexibility of the switch statement also comes a price. It is more error prone. In particular, we might accidentally skip variable definitions. Switch x unsigned temp is 45, case 0 printf something temp may be uninitialized. Such variables are valid, but their initializer may not have been seen. For the example, when x is 0. So in this case, a program execution where x happens to be 0 will be erroneous. Initialization or lack thereof will be discussed in more detail in section 5. Takeaway says that case labels must not jump beyond a variable definition. Prior to C23, the placement of the case labels was even more restricted. They necessarily had to mark a statement. Labels in front of declarations or just in front of the closing brace of a compound statement were not valid. Challenge 2. Numerical derivatives. Something we will deal with a lot is the concept of numerical algorithms. To get your hands dirty, see whether you can implement the numerical derivative double f double x of a function double f double x. Implement this with an example f for the function you use for this exercise. A good primary choice for f would be a function for which you know the derivative, such as sinus, cosinus, or square root. Doing so allows you to check your results for correctness. Challenge 3 pi. Compute the n first decimal places of pi. Summary. Numerical values can be directly used as conditions for if statements. 0 represents false and all other values are true. There are 3 different iterations statements: for, do, and while. For is the preferred tool for domain iterations. A switch statement performs multiple selections. One case runs into the next if it is not terminated by a break. I would say any questions, but I'm kind of feeling glad that we're done. I need to read it all over again for for my own for my own self. I'm gonna put these challenges on the forum just because I don't expect you to go around solving these, but if you like, um, do put some traffic into the forum. I felt like this lesson mixed a lot of things at the same time, so confusion was overlapping. They are way too heavy on math, which has nothing to do with actual C language. I feel it the same way, but at the same time, the way they position all of this math makes me feel, how do I put it? It makes me feel this emotion where I think inside myself, I'm not gonna be able to learn this language and stuff if this is what it consists of. It's the math in this lesson is a little bit of a downer for me. The mood destroyer. The what do you call it? How do you call it when a leader is trying to ramp up something of his team? The word morale. Yeah, yeah. The math here is suffocating my morale. Also, don't like that they use concepts and terms which they haven't even introduced yet, like const expression. This book seems to be aiming for go on, it is going to become clear somewhere down the line. It feels a little bit like that. If it doesn't become clear down the line, then, fuck it. I'm not complaining. It's not a bad book so far. It is a little bit overwhelming in a way that I feel could have been avoided. I'll have to read the following chapters to see if it becomes better by then. Hmm. I'm gonna copy paste some of these things into the forum probably in the morning. Eh, I don't feel like working on this more today. You know, what confuses me so far in this book is that is the fact that I have already started reading the K and R book, and I am aware that K and R book is the very first one that is, that tried to explain the language to people who never, um, basically C was implemented in the age when people really needed a way to program different computers. So people really didn't have the capacity or even wanted to learn assembly for different platforms. So C came in the age when uh, the learning process was different. And the K and R book actually gives me a lot basic examples, like practical exercises, like try this, try that, write this code, compare why this doesn't work, see why this works. Like um, it's uh, neither of these two books are for beginners, but I feel like K and R book actually introduces the C language and gives you a proper chance for hands-on. While this one seems to be thinking that I'm some kind of a math professional and that I have some previous programming knowledge and that I want to program some kind of algorithms. And where are the where is the hands-on? Because in the first lesson, when I was typing code, I was typing the code because that's what I have decided. The lesson never told me you should type this code. But in K&R book, it's actually the opposite. The K&R book literally tells you, do type this code and play with it and see why it works. And it kind of makes you involved in the learning process. Rutlex says, imagine if you tried to explain Linux to someone or to someone and then constantly juggle with Linux jargon and also jump from one topic to another instead of following a clear, understandable path. Well, I'm going to try to draw a parallel between that sentence of yours and our LPIC lessons the last year. This year we have only a few, so I mean the LPIC PDF is fairly good and it has a lot of hands-on. That's one thing. And also the fact that me, who is basically presenting something, but at the same time learning together with you, my general Linux knowledge is much higher than my general C knowledge is. My C knowledge is like this. So no matter how good or bad my Linux knowledge is, it's quite a lot bigger than my C knowledge. So most of you have noticed that I would be jumping into any definition from the LPIC PDF where I was able to enrich their own explanation with some of my additional explanation. And I think for many people in the chat, or even those who weren't in the chat but have been following, at least some of those additional explanation from myself and from my um, real life has helped at least a little bit to clear things up, right? Here I have no power whatsoever, we'd say. And I feel like this book should hold my hand a little bit more. Iceblade says apparently chapter 5 and 6 has the stuff we need. Oh yeah, Linux when you know nothing, and some says Wayland X11 display server, and you're new and say that are those things and how they're connected. Well, when it comes to Wayland X11 display server stuff like that, I always look at Linux users in two ways. Either you already know things and you're now um, talking to me in a way that either you wish to know more or I'm the one who wishes to know more. But it's a conversation where both sides are fairly acquainted with the topic. The other situation is where you have a new person in Linux, and that's when I send them usually towards, an easy to use distribution where there is a lot of mouse clicking and no particular need for understanding what is happening under the hood, because there will be plenty of time later to open the hood and see how the engine works. It's really not needed to push new Linux users straight into the fire. It's just going to scare at least half of them. It's not necessary. We have plenty of good noob friendly distributions which are good at shielding the user from the contents that is under the hood. Is it worth entertaining the idea of finding different C-book? I don't think that will be necessary. I think we can continue with this one by combining our mutual strengths. I think we're doing good. Not just me, not just Rootlex, not just Golga Katani, not just Iceblade, not just the new guy in chat. Sorry, I forgot your name. But all of us together, right? There is always someone who says something very useful that kind of pushes the narrative forward. I like it. I like it. I do wish that there be hands-on. I was going to say more hands-on, but there isn't any. Rootlex says K and R doesn't rush, doesn't jump from topic to topic, doesn't use things which they haven't introduced yet. In other words, it's infinitely better structured. Also, why the heck Heron approximation? Use real world examples, not something 99% of people know nothing about and just don't care about. With the Heron approximation, I feel like the author is flexing a little bit. That's subjective opinion. I think he's flexing. Considering K and R, one of these two guys is still alive. I'm gonna send him an email and ask if I can show his stuff on stream. I know he is not the one who can even allow that to me, but actually it's the book publisher. But it cannot hurt. I'm gonna send one email and see if he replies. One could offer to write a program which sums numbers you specify at command line. I don't know what Heron expression is even after this, but if I saw the code, it would make sense, but not the name jargon. This is both easier to implement and to understand, and therefore a better teaching example. Yeah. Sorry, I'm jumping from Twitch to YouTube, but you researched Mac is Poppy. Okay. Okay, if it's Poppy. I'm gonna be honest with you, Poppy is such a stupid name. I'm gonna keep calling it Mac. That is probably the most valuable thing we learned today. Mac is Poppy. The black dots. The black dots. That's Mac. Food, yeah. That's what I have been eating for the past hour. Yeah, it made sense to me that I would uh, do that so that you are aware that it falls apart, you know. I don't know how better to tell you. Oh, by the way, what I was just eating right now, it is what is the name of the store? Bread Club. Yeah, that's the one. But where is their web page? What kind of web page is this? Pastry. Huh? Oh no, no. Where's the stuff that they sell? No, 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 no. Oh, this goes back. The book. Hmm. Um, so annoying. Incorrect. Hmm. It's incorrect. Okay, whatever. Um, Red Club. Oh, there it is. Oh, it's yeah, that's their offer, but it doesn't have pictures. What is this? I thought that I would find a picture, but no. Maybe that's it. Yeah, that's it. That's what I have. That's what I have. 1 kilo. 1 kilo of the um, food called makovniacha. Yeah, Instagram is annoying. Yeah, it's annoying. They have a way of locking you in or making you hate them even more. I have some account on there, but it looks like it's not saved. I might need to forgot my password thingy. Until next time. Yeah. Okay. Goodbye, Twitch, and good.